So in the last video we went from grams to moles or something to moles or moles to something, and that's a one-step sort of conversion. The next few examples are two-step conversions. We're still not dealing with an incomplete equation like we will in a little bit, but we're going to go from like grams to molecules or molecules to liters. We're going to go through two steps. So for those we are always going to need at least two boxes. So in this case, the first example is 22.0 grams of iron oxide. So iron oxide is Fe2O3, and we're going to go to molecules. So for any of these, we have to use our periodic table if we have grams, and we need to figure out the molar mass of iron oxide. So iron oxide like that, we have two irons, and they are 56, and 3 oxygens, they're 16. So with the calculator, 2 times 56 plus 3 times 16. Hold on, let's see, 16, I just did that wrong. 48 plus 56 plus 56. 160. 160 grams per mole for iron oxide. So now we're going to put that here because we're not in moles, we're in grams, so something's going to have to go here to change it. We always have to, in this first column, figure out how to find the moles. Oh wait, next thing it says we want to convert it into molecules. So this column just converted us into, converted to moles. Now this column is going to take us from moles to something else. In this case it's number of molecules, so I need Avogadro's number. You guys need to know this. This is the number of molecules in a mole. So if we look at the first bit, we have 22 grams divided by 160 grams per mole, or this gave us 0.1375 moles. So each mole contains 6.022 times 10 to the 23rd. So let's multiply our moles by that value. And so I get a number that equals, after I do all that, it's not going to fit there. Let's just write it here, 0.83 times 10 to the 23rd. Or if we want to make it a little bit neater and making sure we've got, well, we actually should have 3 sig figs, right? That's 3 sig figs, so I just wrote down 2. Let's fix that, 2.8. Remember, you can go on the SOL, you can go 1 too many or 1 too few, unless they said specifically exactly the right number of sig figs. Anyway, so let's convert that to a little bit better scientific format. 8.28 times 10 to the 22nd. Okay, so quite a few molecules. All right, the next one is liters of carbon monoxide into grams. So same thing, since we're doing a two-step, always start with our given here, carbon monoxide, so CO. And so now liters into moles, well, for that value we need 22.4 because there's 22.4 liters per mole. So if I have 33.5 divided by 22.4, that, oops, I just hit the wrong number, 33.5 divided by 22.4 gives me, that whole thing is telling me that's 1.50, it's actually 1.49 and change moles. And I want it into grams, so to convert moles to mass, now I need the molar mass of carbon monoxide. So carbon is 16, excuse me, carbon is 12, oxygen is 16, so what is that, 28 grams per mole. And there's 1.5 moles approximately, so 28 times that value I got. And my number's a little bit different because I did not round in my calculator, but let's see, 3 sig figs, right? So 41.9 grams. Okay, so I'm going to leave the next two for you guys, and in our next video we will go through the big complete stoichiometry problems. But let's end by defining what stoichiometry is. It's a quantity, some sort of quantifying the relationship between components of a balanced equation. So in other words, we're comparing masses to masses, we're comparing masses to moles, things like that, and we're going to do that starting with this first example in your packet of this weird replacement reaction. All right, so in the next video.